Hey guys, and welcome to my video on solving systems of equations using elimination. So I'm going to go through a couple different problems showing all the different possible situations you can see yourself in when you're solving systems of equations. So first we're going to start with elimination that has addition or subtraction, and you're going to use this when your x coefficients or your y coefficients are the same. And my two examples right here show that we've got our y's in common and our x's in common. So first things first, I have my problem up here in the upper left corner, and I have to ask myself which variable has the matching coefficients. So it's up to you how you want to do this. I'm personally just going to draw right around it, and I notice that I have my x's both have a coefficient of 2. So I can say x has the matching coefficients. Next, are the signs on the matching coefficients the same or opposite? So here I can look once again, and I see that I have a positive 2 and a negative 2, which means that they are opposite. So I'm going to go and say opposite. And finally, to eliminate, will you add or subtract? And so opposite signs are going to be adding. Same is subtract. So think same, subtract, both start with S's. Opposite, add, both start with vowels. So I'm just going to say that we are indeed going to be adding here. Because we have these opposite signs, we're going to be adding. So next we're going to be solving for our variable. And to solve for our first variable, we are going to do what we said, which is we are going to add our system of equations. And to do that, I'm just going to take my text box tool. I'm going to rewrite exactly the equations that I have right here. And when I do this math, I have to add. So I'm using a different color here to show that this plus does not take away from the fact this is a negative 2x. When you solve for your first variable, you're going to notice that we have this 2 plus negative 2x. That's going to cancel out and become 0x. So I'm not even going to write anything down here because there's not really a point in it. Then I have 3y plus 4y. That, in this case, gives me 7y. And forgive my handwriting on this video. It's not going to be the absolute best. And then finally, I have 16 plus 12. And 16 plus 12, after doing some quick math, is 28. Now we're left with a one-step equation. We have 7y equals 28, so I'm going to divide both sides by 7. And finally, I'm going to write in blue, 28 divided by 7 is 4, so y equals 4. We've officially done the first half of this problem. So to solve for the second variable, I actually wrote the steps down here. We substitute, multiply if needed, then add and subtract, and then divide. So first we substitute. I'm going to take that y equals 4, and I'm going to rewrite it into the original equations that I had. Now it doesn't matter which one I pick. I can choose the top one or the bottom one. I personally like dealing with positive numbers when I can, so I'm actually going to create another text box, and I'm going to say 2x plus 3y equals 16. And I'm just going to substitute. So when I substitute this, I have 2x plus 3 parentheses 4 close parentheses equals 16. We did that substitution. Next is multiply, and we multiply when there's a number directly to the left of our parentheses, which in this case there is. That number is 3. So we're going to do that multiplication. And if you'd like, I can actually color code this. So it'll be 2x plus 12 equals 16. Now I'll color code it so you can see that this step was the multiplying. Then next we have add or subtract. We want to get our constants onto the same side. So in this situation, I'll actually color code this one green for adding or subtracting. So when we do that addition or subtraction, we're going to do 16 minus 12. That leaves us with 2x equals 4. And finally, we have to divide. And dividing is going to be in yellow in this case. We have 2x equals 4. So that means that x needs to equal 2. So x equals 2. So finally, we can write our answer here in coordinate form. As we know, coordinates are written in alphabetical order. And then in the alphabet, we have x, then y. So our final answer for this problem is going to be parentheses 2, 4. And that is your final answer for this problem. Next, we're going to move on to a different problem that involves eliminating y first. All right, so here is our second example involving addition or subtraction. So here we've got 2x plus y equals 10 and 3x plus y equals 14. So our first step is once again to see which variable has the matching coefficients. And here we see that it's y in this case. Y has a coefficient of 1 in both of our equations. So I'm just going to write y has matching coefficients. Next, are the signs on the matching coefficients the same or opposite? So I'm going to look at my two y's. They are, in fact, the same. They're both positive y's, so I'm going to say these signs are the same. So to eliminate, will we add or subtract? Just as I said in my last example, subtract same or same subtract, which means that we will be subtracting in this example. So next I'm going to come over here onto my right panel, and I'm just going to do the same thing as always. So I'm just going to retype my equations. And I'm going to solve for them. So if we solve, we said that we are subtracting in our first segment. So I'm going to go and, oopsies, there we go, subtract. So I have 2x minus 3x. That gives me a negative x. Y minus y gives me 0, so I'm just going to not even write that. So I have equals 10 minus 14 gives me negative 4. So if negative x equals negative 4, I just have to divide by negative 1 on both sides. So we can have a positive x. And negative 4 divided by negative 1 gives us an answer of x equals 4. That's the answer to the first half of this problem. So if x equals 4, we can once again take that and substitute it into another equation. So once again, I'm going to choose my top equation because I like the numbers in it more. They're a little bit smaller, so they're easier to work with. So I'm going to rewrite my equation as it usually is, 2x plus y equals 10. And then from here, I'm going to once again do the same thing. That was my substitution, so I'm going to multiply. I'm going to put my multiplication in blue just to show where that multiplication is going to be after we substitute. But before we do that, we still have to do our substitution. So we have 2, and then we said x equals 4, so it's going to be parentheses 4 plus y equals 10. Once again, multiply if needed in this circumstance, which we do because right to the left of our parentheses, there is a 2. So in blue this time, I'm going to show you how we do that multiplication. We have 2 times 4, which is 8, plus y equals 10. I realign my equal signs really quickly. And then after we do our multiplication, we add or subtract. And once again, I'm going to put this in green just to kind of show that step. So if we subtract 8 from both sides, because we want y to be by itself, we say that y equals 2. And now division is only necessary in this step if we have a coefficient in front of our y, but we don't, so we can just leave it as y equals 2. And finally, we have to write our coefficient in coordinate form. So I'm just going to type that in my final box. Once again, in alphabetical order, we have 4, 2. In our final 2 examples, we're working with elimination with multiplication. And we use this if your x coefficients don't match and your y coefficients don't match. For example, 2 and 6 don't match, 4 and 3 don't match, 3 and 5 don't match, and 2 and 6 don't match. So we have to use multiplication to make them match. Let's look at our first example. We've got 2x plus 4y equals 6, and 6x plus 3y equals 0. So we've already established in our previous slide that there are no matching coefficients here, so we have to make our own. And we do this by first looking at our x and asking ourselves, does one of these x's evenly multiply into the other x? And in this case, that's true. 2 can evenly multiply into 6. And 2 can multiply into 6 3 times. So we can put parentheses around this entire equation and multiply it by 3. And we do that with distributivity. We're going to take that 3 and multiply it to every term on the inside. So when I do that, I can type it over here. We have 3 times 2, which is 6x, 3 times 4, which is 12y, and 3 times 6, which is 18. For our bottom equation, we're just going to leave that completely alone, so just rewrite it as normal. And this will be our new system of equations to work with. So we did make our own, and now we can ask ourselves which variable has the matching coefficients. So once again, looking at our x's, we now see that 6 and 6 do match. So I can write with confidence, x has matching coefficients. Next, are the signs of the matching coefficients the same or opposite? Well, both of our 6's are positive 6's, so they're the same. To eliminate, do you add or subtract? Once again, same, subtract. So in this case, we are going to subtract. So I can take this system of equations and just plop it right over here. And as we said, we are subtracting. I like to use a different color to show subtraction just so I don't accidentally rewrite it as a negative in the future. When we do that subtraction, we have 6 minus 6, that becomes 0, so I can just cross that off. 12 minus 3 gives us 9y. And 18 minus 0 gives us 18. Finally, we have to divide by 9 on both sides to find out what y is. So we say that y equals 2. So if y equals 2, we can substitute that. So we're going to go down to our bottom left box over here. I personally am going to substitute it into my, actually, you can really substitute into the top left over here or the bottom right. It's kind of a preference. Personally, I'm actually going to try to substitute into the bottom, the 6x plus 3y equals 0. And the reason why is because it has a 0 in it. I just like working with 0 because it's a lot easier of a number to do any sort of math with. So in this case, I'm going to substitute y by retyping this equation. And it's going to be 6x plus 3 parentheses 2 equals 0. So there's our first step here, is just that substitution. Next, we're going to multiply, and that's something we're going to do here because we have that 2 on the inside of the parentheses, and to the left of those parentheses, we have a number, which is 3. So once again, I'm just going to color code this just to kind of show you where I'm getting these different things from. So when I do that multiplication, I find that I have 6x plus 6 equals 0. I'm just going to align my equal sign so you see what happens each step. Next, we're going to add and subtract. So here we do have addition, so we have to do the opposite, which is subtract on both sides. So I'm going to subtract 6 from both sides to get my x completely by itself. And that gives me 6x equals negative 6. And finally, our division step, which I'm going to put in yellow. 6x equals negative 6, so we divide by 6 on both sides, and we get x equals negative 1. I'm going to put that quite a bit larger since that is our answer for our variable. So we have x is negative 1 and y is 2. So as our collective answer, we can write parentheses negative 1, comma 2. And finally, let's work on our final example. So here we have 3x plus 2y equals negative 10 and 5x minus 6y equals 30. So same process as before. We've noticed that there are no matching coefficients. So we look at our x's, see if one multiplies into the other. In this case, they don't. 3 does not evenly go into 5. But if we look at our y's, we see that 2 evenly goes into 6. And 2 evenly goes into 6 3 times. So I'm going to put some parentheses around this and multiply it entirely by 3. And we use distributivity, do that 3 times each term on the inside. So I'm going to rewrite that over here. We've got 3x times 3, which is 9x, 3 times 2, which is plus 6y. And then we have equals 3 times negative 10, which is negative 30. And I don't actually need the parentheses right there, so I'm going to get rid of it. And then finally, our bottom equation, I'm just going to write as usual. And so this is going to be our new system of equations that we work with. So once again, which variable has the matching coefficients? In this example, it's going to be y. So I'm going to say y has matching coefficients. Oopsies. Are the signs on the matching coefficients the same or opposite? If I look at my y's and I look to the left of them, we've got a plus and a minus. So I'm going to say that they are opposite. And because they're opposite, we will be adding. So I'm going to take my system of equations, put it over here, and we're going to solve for our first variable. So we said that we're going to be adding. So I'm going to make a plus sign right here. And then we just got some math to do. So we've got 9 plus 5, which gives us 14x. We're eliminating y in this situation, so we just can write equals. Negative 30 plus 30 gives us 0. And this one works out pretty nice and even. So we have x equals 0. So we can take that x equals 0 and substitute it into any of our equations. In this example, I'm going to use the upper left one over here, just because, once again, we're back to that smallest numbers one, but you can really take any equation and use it for substitution. So here, I'm going to do 3x plus 2y equals negative 10. To substitute, I'm going to put x in as 0, so it'll be 3 parentheses 0 plus 2y equals negative 10. Now here we have our multiplication, which once again I'm going to be color coding for the sake of showing you where each step is happening. And we have 3 times 0, which is 0, so I can just kind of leave it as is and call it 2y equals negative 10. Now here we don't have to add or subtract, and that's because there's really nothing to add or subtract at this point. So if you don't need that step, you can kind of just move on. And here I'm going to be dividing, because that's all that I have left. I've got 2y equals negative 10. So if 2y equals negative 10, that means that y equals negative 5. And finally, we can write our answers in coordinate form. X comes first, so 0, comma, negative 5. And that is how you do it. So if you have any questions, just let me know. Hopefully this was a relatively thorough video. It was longer than I'm sure you wanted it to be, but hopefully it helps you out with any of your questions that you have.